Hi guys, today we're going to talk about different forms of a quadratic function. Depending on the form that your quadratic is in, there are certain things that you can pull out easier when a quadratic is in like standard form versus root form or factored form versus vertex form. Okay, so far we have looked at quadratics primarily and been graphing them primarily in standard form. You can also see a quadratic in what we call factor form. And remember in the last unit, we were taking quadratics that looked like this, and to solve them for the roots or for the zeros, we were factoring them. All right, we were just putting 0 in for this y value. So if you have a quadratic equation and you can write it in factored form, it is going to be really, really easy to find the zeros or to find the roots. So when your equation is written in this factored form, you would be able to plot those roots easily. When you have it in standard form, one point that is very easy to pull out when it's in standard form is that y-intercept. So kind of if you manipulate your quadratics, you can pull out several points and be able to graph your quadratics easily. Okay, let's take a look at a couple of examples. So first thing, let's take our original equation is y equals x squared plus 6x plus 5. Okay, now this is written in standard form. Well, I want to know what my zeros are, so I am going to write this in factored form. This is, again, like I said, like last unit, I'm going to set the equation equal to 0. Okay, so now what I'm going to do is I'm going to factor this. When I factor it, I know I can split this up into x plus 5 times x plus 1. Okay, I'm going to go through and solve for my zeros or my roots. So I would subtract 5 from both sides, and I know that one of my roots is going to be negative 5. And then I'm going to subtract 1 from both sides, and I know my second root is negative 1. So these right here are my zeros, my roots, or they may also be referred to as the x-intercepts. Okay. Another thing that you can find is you know that if you are graphing your zeros or your roots, let's say we plot the point negative 5 right here and negative 1 right here. We know that quadratics are symmetrical. So if you know your roots, you can find that axis of symmetry by just dividing or finding the middle point between your two roots. You can use this formula right here. X1 would be one of your roots plus x2 would be this other root, and then just divide it in half. So if I were to say x1 plus x2 divided by 2, this is going to give me my axis of symmetry. So I'm going to think negative 5 plus negative 1 all over 2. I get negative 6 divided by 2. So x equals negative 3. This is going to be my axis of symmetry. Okay? So I know this line is going to split my graph. Okay? If you know the x value of your axis of symmetry, you can then find the vertex because you can substitute in negative 3 into your equation. Now you can do this when it's written in standard form, or you can do this when it's written in factored form. It doesn't matter. You're going to get the same y value. I'm going to use the standard form to find the vertex. So I'm going to plug in negative 3 for my x value plus 6 times negative 3 plus 5. So my y value ends up equaling negative 4. So the point negative 3, negative 4 is going to be my vertex. Okay, so I could plot that point, negative 3, negative 4. There's my vertex or my turning point. All right, so I know that negative 3, negative 4 is a point, I know that my roots were -5, 0, -1, 0. And then if I go back and I look at my standard form, I know that the y-intercept is +5. So I can plot that point. And again, if this is my axis of symmetry and I have a point that's right here, that's 3 units away from the axis of symmetry, I could plot another point 3 units to the left of the axis of symmetry, and that would give me a 5th point on my graph. And I did all of this without putting it in the calculator. Connect the points and make a nice curve. So that is what you could pull out of an equation if it is written in factored form, okay? And you guys should be good at converting from standard form to factored form. Okay, so here's another example where it is written in, it's already in factored form. So let's pull out the important pieces from this example. So first thing is, I can find my roots, again, by setting this equal to 0. So I'm going to set each factor equal to 0 and then solve them. Add 4 to both sides, and I get x equals +4. Okay, so these are my roots right here. So I know I'm going to go through -1, and I'm going to go through +4. Okay, I can also find my axis of symmetry again by finding the average of the roots. So I'm going to think -1 plus 4 divided by 2. So I'm going to get 3 divided by 2. I get 1.5. And remember, that's my axis of symmetry. So 1.5 is going to be right here. So this is that axis of symmetry that's going to divide my graph down the middle. Okay, since I know that my axis of symmetry is 1.5, what I'm going to do is I'm going to find my vertex. And I'm going to use the factored form to find my vertex. So I'm going to substitute in 1.5. Actually, let me erase that. I'm going to run out of room. So I'm going to substitute in 1.5 plus 1 times 1.5 minus 4. Okay, when I plug those in, I end up with positive 2.5 times negative 2.5, so I get y equals negative 6.25. So I know negative 6.25 is about here. That's going to be my vertex point. So when x is 1.5, my y is negative 6.25. My roots, I have, let's see if I can pull out what the y-intercept would be in this case. So the y-intercept, remember, is when x is 0. Since this is written in factored form, I can't just look at that c value, but what I can do is I can substitute in 0 for x, and that would give me my y-intercept. So if I plug in 0 for x, I get 1 times -4. So y equals -4. Okay, so when x is 0, y is -4. So I can plug that in right here. Now I'm going to use the fact that I know that this is symmetrical. So this point was 1.5 units away from the x-axis. So I'm going to graph a point 1.5 units to the right of that axis of symmetry. Okay, so now I know that the point 3, -4 was also a point on my graph. And then I had my roots that I had found very first thing in the problem. And now you have 5 points and you can connect with a nice curve. Okay, so that is going back and forth in, between standard and factored form and what you can pull out of the equation if it is written in factored form. And I'm just going to jot down right here. This was 1.5 -6.25. That was our vertex. Okay. All right, the next form that we're going to look at is what we call vertex form. Vertex form, if your quadratic is written in vertex form, the part that's easy to pull out is your axis of symmetry and is the vertex point. Okay, so when a quadratic is written in vertex form, pretty much what it is you're taking your standard form and you're going to go through the steps that you would when we were solving by completing the square. Okay, the only difference is you're not going to move any numbers to the left side of your equation. You're still always going to have y equals. We're not moving anything over. Okay, so let's go through and convert standard to vertex form. All right, remember, when you have your standard equation, to complete the square, we are going to look at the b value, okay? So in this case, our b value is 8. So what I have to do is take my b value, I'm going to cut it in half, so I'm going to think 8 divided by 2, I get 4. Now I'm going to take that number and I'm going to square it. So I get 16. Now remember when we were solving these, we added 16 to this side, to the right side, and then we added 16 to the other side to keep things balanced. What you're going to do this time is you are going to add 16 to the right side. Now, so that you don't change the value of the equation, remember I said we weren't going to add anything to the left side of our equation here? So you don't change the value of the equation. Not only are you going to add 16, you're going to subtract 16 also. Because what this is essentially saying is that you're adding 0 to the right side of the equation. You're just writing it out a different way. So now what you have is we have y equals x squared plus 8x plus 16 minus 16 plus 12. And there's a reason why I'm writing it in this order. Because remember, we are trying to complete the square. And when we were adding this 16 on here, that's what was going to make the perfect square binomial. So now, right here, that is our perfect, right here is our perfect square trinomial that we can make a binomial squared. So I can write x squared plus 8x plus 16 as the binomial x plus 4 squared. Remember, these two things mean the same thing. I'm just writing in a different way. Now, what I have left, I have to add these two together. So negative 16 and 12 will give me negative 2. Okay? So now the important parts of this, that it's written in vertex form. Up here, you'll see. We can find our vertex by always taking the h value, okay, and it's always going to be the negative h value. You want to think negative h. That is going to be your x coordinate of your vertex, okay? Then over here, your k value is always your y value of your vertex, okay? Also, you know, if this is the x value of the vertex, that is also your equation for your axis of symmetry. So when I look at this equation, I'm going to think x, another way of writing x plus 4 would be like x minus negative 4 squared minus 2. So now you can see a little bit better why -4 is going to be the x-coordinate of my vertex. And then -2 is the y-coordinate. All right, and I also, since -4 is my x-coordinate of my vertex, I can also say that x equals -4 is the equation for my axis of symmetry. And those are two things that we can pull out easily when it's written in this form. Okay? All right, let's look at another one. So I have my quadratic equation here. I want to first write this in vertex form. So I have to complete the square. But remember when we were solving quadratic equations, the first thing that we did was you want to see if you can pull out any factors first and see how I can divide 2 into all 3 terms. So I'm going to pull that out first. Okay, now I'm going to look at this portion right here. And I notice in this portion, this is already a perfect square trinomial. So I can rewrite this as x minus 2 squared, okay? Because again, if you look at your b value, it was -4. If we divided that by 2, you get -2. -2 squared, you get +4, and that's what's being added on. So this was already a perfect square trinomial. All right, now I have my equation written in vertex form, and I can pull out my vertex easily. So right here, my x value is going to be +2, because remember, this x minus h is that standard vertex form. So the 2 is your x value. And then since this is technically saying like +0, our k value is 0. So 2, 0 is going to be the vertex. I could also say that my axis of symmetry is x equals +2. Okay. All right, let's take a look at a graph. Okay, so if I'm given my equation in vertex form, the first thing that I can do is, again, I can pull out that vertex really, really easily. I look at this, and I know that my x value is going to be +3, and the y value is going to be -4. That's my vertex. So I'm going to plot +3, -4. All right, so now I'm just going to pick a couple of values that I can plug in really easily. Let's do when x is 0. Okay, if x is 0, all right, I'm going to get 2 times -3 squared minus 4. -3 squared is going to be 9. 2 times 9 is 18. 18 minus 4 is, it's going to be off the grid, so I don't want to do 0. Let's keep it closer. It's going to end up somewhere up here, and I want to be able to graph. It's going to end up somewhere up here, and I want to be able to graph it. All right, let's do 2, 1, 4, and 5. All right, so let's just plug these in. 2 times 2 minus 3 squared minus 4. So 2 minus 3 is -1. -1 squared is 1. 2 times 1 is 2. And 2 minus 4 is -2. So I can plot the point 2, -2. And again, this is going to be, since that's my vertex, this is that axis of symmetry. So if I plotted a point at 2, -2, that's 1 unit to the left of the axis of symmetry, I can plot a point 1 unit to the right of the axis of symmetry, and I now have a third point, 4, -2. All right, now let's plug 1 in. So 2 times 1 minus 3 squared minus 4. So 1 minus 3 is -2. -2 squared is 4. 2 times 4 is 8. 8 minus 4 is 4. So I can plot the point 1, 4 right here. This is 2 units to the left of the axis of symmetry, so I can plot another point 2 units to the right of the axis of symmetry. So now I have the point 5, 4. And I can draw a nice curve going through the 5 points that I had just plotted. Okay. All right. And then the last thing is converting from vertex form or from factored form, converting it into standard form. Okay. And all you're going to do is you're going to multiply the problem out. So for example, let's say you were initially given a problem that was written in vertex form like this. So all we would do is go through the steps and multiply this out. All right, order of operations, I would have to do x minus 3 squared first. So that's going to give me x minus 6x plus 9. Bring down the minus 4. Now I'm going to distribute. So I'm going to get, this should be x squared, 2x squared minus 12x plus 18 minus 4. And then the last step would be just to combine those like terms. So I get 2x squared minus 12x plus 14. All right, so that's converting from vertex form into standard form. All right, and then the same thing if you have an equation that's in factored form, we can change this into standard form by just FOILing it out. So you would get x squared minus 4x plus x minus 4. Combine your like terms. Oops. Minus 3x minus 4 would be that final answer. Excuse me. Okay. All right. I hope this helps. Your homework is attached. And if you have any questions, feel free to email me. I will be holding a Google Meet on Friday, so check the calendar and Google Classroom for that time. Have a good day, guys.